So for our last area and perimeter review, I'm going to look at hexagons. Now, this one might actually not be a review for some of you. You might not have seen this hexagon before. So what I am working with is, we're going to call it a regular hexagon. Okay, so we are working with a regular hexagon. And the regular hexagon, that means that all sides are the same length, as well as all angles are the same measurement. So all these little angles inside the hexagon are also the same measurement. They work out to be 120 degrees. So I'm just looking at a regular hexagon for this one. So with the regular hexagon, perimeter is pretty easy. I can do perimeter no problem. Okay, when I look at the perimeter and I think about going around the outside, pick anywhere for our little guy to stand and walk around. So he's going to walk around this way. 6, 6, 6, 6, 6, and then 6 more till he gets back to where he started. So when I think of the perimeter, it's 6 plus 6 plus 6 plus 6 plus 6 plus 6, and that's 36 centimeters. Now I could have come up with a little formula and I could have said 6 times the side length, and since the side length was 6, that becomes 6 times 6, and it's the same thing. Okay, now I don't necessarily need this formula because perimeter is fairly easy to get without the formula. Add all the outside lengths together. Now, area is a little bit trickier. So with the area, what I've done here is, you might have played with these pattern blocks when you were a kid in elementary school. And those pattern blocks, I should have probably used the same colors, I guess, but the big hexagons, remember, were yellow. Those were the color of the big hexagons, were yellow, and then the small triangles that we had were green. And if you think about the small triangles, I'm going to show you here, I took this small triangle and I put it on top of that hexagon, like this. Kind of put it right there. And it doesn't work perfectly on the tablet. There we go, pretty close. So there you go, I've kind of taken my triangle that was here, and I took it away. I just put it on the other one just for demonstration. And if you look, I'm going to pull all of these kind of off of my hexagon. And I had 6 of those orange triangles covered that pink hexagon. So really, all I need to find is the area of one of these triangles, and then I'm going to multiply it by 6, because there are 6 triangles in total. So my area formula is going to be the base times the height divided by 2. Why do I choose that? Well, I need to find the area of a triangle. And if you watch the triangle review, area of a triangle is base times height divided by 2. But I don't have just one triangle. In this case, I have 6 triangles. So I'm going to take that answer and multiply it by 6. Now, I took that first triangle that was right here, and I moved it over here kind of purposefully, and I moved it here because now I can see when I put it in, I have a height from the bottom, or the base, that goes up to the top or of the triangle, or really the middle of the hexagon, and that height is 5.2. So my base, this part here, that's just the outside dimension, which is the same as this one, so it's 6. So I've got 6 times the height, we said, 5.2. So I'm going to multiply 6 by 5.2, and then I'm going to divide by 2. And after I do that, I'm then going to multiply by 6, because I'm going to find the area of one triangle, and then multiply it by 6, because there are 6 triangles. So this part here, 6 times 5.2 divided by 2, that gives me 15.6. And I need to then multiply by 6. And when I multiply it by 6, I'm going to move up, I guess. I'm kind of running out of room. We get 93.6 centimeters squared. Reminder, centimeters squared is always what we get for an area. Centimeters would be what we get for a perimeter. And that is how we find the area and the perimeter of a hexagon.